Hello everyone, welcome to my channel. Today's subject is Internet of Things. In that today's topic is introduction of Raspberry Pi. Before discussing the topic, let me introduce myself Trisha PV. I am from Sri Venkateshwara College of Engineering, Department of Computer Science Engineering, pursuing in 4th year 8th sem. What is Raspberry Pi? The Raspberry Pi is a series of small single board computers developed in the United Kingdom by the Raspberry Pi Foundation to promote the teaching of basic computer science in schools and in developing countries. The original model became far more popular than anticipated, selling outside of its target market for users such as robotics. Over 5 million Raspberry Pis has been sold before February 2015, making it the best-selling British computer. By November 2016, they had sold 11 million units. This is the model of Raspberry Pi 3 model. Features. All models feature a Broadcom system on a chip SoC, which includes an ARM compatible central processing unit CPU and an on-chip graphics processing unit GPU, a voice core. Fourth, CPU speed ranges from 700 MHz to 1.2 GHz for the Pi 3, and on-board memory range from 256 MB to 1 GB RAM. Secure digital cards are used to store the operating systems and program memory in either the SDHC or micro SDHC sizes. Most boards have between 1 and 4 USB slots, HDMI and composite video output, and a 3.5 mm phono jack for audio. Operating system. The foundation provides Raspbian, a Debian based Linux distribution for download, as well as third-party Ubuntu, Windows 10 IoT cores, RISC OS, and specialized media center distributions. It promotes Python and Scratch as the main programming language, with support for many other languages. The default firmware is closed source while an unofficial open source is available. Hardware. This is the hardware diagram: RAM input, CPU or GPU, USB hub, Ethernet 2 into USB. This block diagram depicts models A, B, A plus and B plus. Model A, A plus and the Pi 0 lack the Ethernet and USB hub components. The Ethernet adapter is initially connected to an additional USB port. In model A, A plus and the Pi 0, the USB port is connected directly to the system on a chip. SoC means nothing but system on chip. On the Pi model B plus and later models, the USB or Ethernet chip contains a 5-point USB hub, of which 4 ports are available, while the Pi 1 model B only provides 2. On the Pi 0, the USB port is also connected directly to the SoC system on a chip, but it uses a micro USB port. Processor. The Broadcom BCM2835 system means SoC used in the first generation Raspberry Pi is somewhat equivalent to the chip used in first modern generation smartphones. Its CPU is an older ARM v6 architecture, which includes a 700 MHz ARM 1176JZF S processor, video core, fourth graphics processing unit, and RAM. It has level 1 cache of 16 KB and level 2 L2 cache of 128 KB. The level 2 cache is used primarily by the GPU. The SoC is stacked under the RAM chip, so only its edges is visible. The Raspberry Pi uses a Broadcom BCM2836 SoC with a 900 MHz 32-bit quad-core ARM Cortex A7 processor with 256 KB shared L2 cache. The Raspberry Pi 3 uses a Broadcom BCM2837 SoC with a 1.2 GHz 64-bit quad-core ARM Cortex A53 processor with 512 KB shared to L2 cache. Performance: the Raspberry Pi 3 with a quad-core Cortex A53 processor is described as 10 times the performance of Raspberry Pi 1. This was suggested to be highly dependent upon task, threading, and instruction set use. Benchmark shows the Raspberry Pi 3 to be approximately 80% faster than the Raspberry Pi 2 in parallelized tasks. Raspberry Pi 2 includes a quad-core Cortex A7 CPU running at 900 MHz and 1 GB RAM. It is described as 4 to 6 times more powerful than its processor. The GPU is identical to the original. In parallelized benchmarks, the Raspberry Pi 2 could be up to 14 times faster than Raspberry Pi 1 model B+. RAM: the Raspberry Pi 2 and the Raspberry Pi 3 have 1 GB of RAM. The Raspberry Pi 0 and 0W have 512 MB of RAM. This is nothing but the RAM. Thank you everyone. Please like, share, subscribe.